Welcome to our presentation on open protocols in aquatic telemetry. Today's presentation is presented by David Gambin, Donna Kehoe, Erik, Marlin, Gregor, and Stijn Bruneel. The open acoustic protocols that we will be discussing has been spearheaded by the ETN in collaboration with Lotek, Sonotronics, Thelma, Biotel.
Acoustic telemetry has been used for more than half a century to collect movement and behavioral data from aquatic species. Driven by the need for data to understand detailed movement of salmon in the Columbia River in relation to dams, in 1956 the U.S. Fish and Wildlife Service initiated the development of underwater sonic equipment. In the decades that followed, telemetry equipment suppliers emerged and began to design, manufacture, and supply acoustic/sonic telemetry equipment. Companies such as Sonotronics, Vemco, HTI, Lotek, Thelma Biotel, and ATS, each, for the most part, working independently. Responding to requests from the scientific community, government, and commercial fisheries organizations, manufacturers develop specialized systems to gather data to answer specific questions. Systems adapted to function in a variety of conditions with a broad variety of species. Systems best suited to monitoring a few transmitters, and systems suited to monitoring many co-located transmitters. This led the companies to develop their own proprietary coding schemes, and these systems are unique to each manufacturer and not interoperable. In order to monitor animals throughout the course of their lives, it's necessary to have the ability to track them across large distances and between different environments. The Pacific Ocean Shelf Tracking Project was developed to study the life history of Pacific salmon. This project involved the establishment of a continental-scale acoustic telemetry system, including receiver arrays along the continental shelf and in rivers, thus linking two very different environments. In 2007, the Ocean Tracking Network was created. As it has done for the past 14 years, the Ocean Tracking Network continues to foster collaboration and data sharing between scientists, supporting the installation of Vemco receiver arrays and the establishment of telemetry networks across the planet. Sonotronics, Thelma Biotel, and Lotek have been offering interoperable equipment which is compatible with Vemco equipment for more than a decade, working together to manage ID space to ensure no duplicate codes are produced.
Lotek Wireless has been in the business of wildlife telemetry since its inception over 37 years ago. A world leader in the design and manufacture of wildlife telemetry systems, Lotek has manufacturing locations across the globe. Lotek's headquarters are in Newmarket, Ontario, Canada. It also has facilities in St. John's, Newfoundland, Canada, Wareham, United Kingdom, and in Havelock North, New Zealand. Lotek delivers innovative tracking systems crossing a myriad of technologies, including acoustic, radio, archival, and satellite. Lotek has advanced wildlife science by tracking animals of almost any size in almost any environment.
Hello, my name is Marlin Gregor, and I'm representing Sonotronics. Sonotronics was founded in 1971 by Don Brumbaugh, a rather colorful RF engineer who developed systems for tracking terrestrial animals, including elephants and polar bears, and can be seen in some early National Geographic videos, trying to put a collar on top of a barely anesthetized polar bear. Pretty interesting. But it was Don's work with Archie Carr trying to track sea turtles crossing the Atlantic Ocean using torpedo-shaped radio transmitters that engendered the idea of using acoustic transmitters in order to track aquatic species. Don started to innovate using multiple frequency transmitters to identify individuals, and in 1982 developed one of the early PPM systems in order to permit the unique ID of a few hundred individuals using a simple algorithm. Don also continued to innovate, and in 1984 developed the first submersible acoustic tag receiver that actually used paper tape to record the occurrence of pings, and then using the PPM system he developed, be able to use a ruler to actually identify what ID of the transmitter that was being detected. Don continued to rely on word of mouth in order to promote his products, and since 1971, Sonotronix has developed relationships with researchers around the world.
Thelma Biotel is a company providing acoustic telemetry gear. The roots of the company goes back into the early 1970s, when the first technology was developed here in Trondheim at the university and a research company called Sintef. The products were first developed and commercialized under the research company Thelma in 2001, and later as an independent company from 2008. We as a company, we concentrate only on acoustic animal telemetry equipment and underwater communication. We provide telemetry data loggers, acoustic releases, real-time data cloud access systems, and a wide array of transmitter tags. Transmitters are ranging down from size 6mm to 56mm of diameter. Most of the users of the Thelma Biotel technology are found in Norway and Europe, but we also have equipment present on all continents around the world.
In addition to maintaining their own proprietary systems, Sonotronics, Thelma Biotel, and Lotek have worked cooperatively for the past 14 years, providing interoperable equipment to the acoustic telemetry community. This is the current state of equipment compatibility between manufacturers. Protocols of the same color are compatible. The use of tag protocol MAP 115 removes all interoperability, stifling competition, innovation, and manufacturer collaboration, driving the need for change. And so a new open protocol coding scheme was developed. This supports an interoperable system. It's an open protocol that's managed by the telemetry user community and is open to participation from all manufacturers. Currently, there are 4 manufacturing companies that have agreed to the terms of the Memorandum of Understanding regarding the use of OPI and OPS tag protocols with the European Telemetry Network: StarOd, Lotek, Thelma Biotel, and Sonotronics. Vemco and ATS were invited to participate in this new interoperable system. Vemco provided some assistance with the technical aspects of the protocol, but has not yet committed to the Memorandum of Understanding with the ETN. ATS elected not to participate at the time. And StarOd, we expect, is currently developing interoperable OPI and OPS equipment.
Open protocol characteristics and the technical details about the protocols. Because actually, open protocol is not just one communication protocol, it's 2. There is OPI, which is the protocol for ID tags, and there's a second one, OPS, which is for sensor tags. Those 2 are different. OPI and OPS, they are both pulse position modulated protocols, PPM, just as the other PPM protocols like R64K, or which is also called A691303, and all the other proprietary PPM protocols used by the different manufacturers. In PPM protocols, pulse position modulated, the information of a transmit is encoded into the intervals between the different pulses. Pulses are about 10 milliseconds long, so you can actually hear them, and the intervals are some hundreds of a millisecond long. So it's a really simple, it's a robust protocol. It uses quite a little battery power, so you have tags which have a long range and they have a long lifetime. It's quite well known, it's quite old, but it works really well. That's why it's chosen. About the power of the open protocol, because those two protocols, they really have quite a lot of power to them. For OPI, for example, there is over 1 million unique IDs available. If you compare that to R64K, which is one of the shared protocols, it's 65,000 unique IDs. So with OPI, we can really make quite a lot of tags before we have to reuse any of the IDs. Also for the OPS, there's quite a lot of IDs, sensor tags IDs. There's 65,000 sensor tags IDs. That's because the sensor protocol, it has to share the data in a transmit between IDs and also for the sensor data. So there's less unique IDs, but there's still quite a lot more than in other protocols. So in the open OPS system, OPS protocol, it carries a data value with also a greater resolution than other protocols. It has 4,096 points of resolution rather than 256, which is found in many other protocols. So this means you can have much finer details in your data. For example, if you have take a depth sensor, for example, it's with 256 points of resolution. If you would like to have 10 centimeters water depth of resolution, you can only work with a range of 25.5 meters, for example, from 0 to 25.5 meters. So if your tags should go deeper than that, they will still just read 25.5 meters. So that makes it really important to choose the right range. For OPS, there's with those 4,096 points, you could actually have 10 centimeters resolution all the way down to 400 meters. You don't have to think about the range anymore. It's really versatile and simple to use. Also, there is a mechanism which you call the checksum. And what the checksum does is that it reduces the false detections, the amount of false detections. It's a security mechanism to ensure that the transmit which it has come through is actually a transmit. So in dense settings where you have lots of collisions between transmits, you normally get quite a lot of false detections, because you could have interpretations of those collisions which match and gets interpreted as a data value. With OPS and OPI, this is a much better checksum. It uses more data, so it uses more pulses, but you really get that back in security in your data. So in a dense setting with older protocols, you normally see maybe 2 to 3% of your data is false detections, and in the same dense setting with OPS and OPI, you will probably not see more than about 1 to every 1,000 detections as a false detections. That's what we have seen. So really much safer choice there. For a PPM protocol, the primary identifier is the interval between the two first pulses. That's how the receivers know which kind of language or which kind of protocol it's going to interpret and listen for. So when it hears those two first pulses and the interval, it knows what kind of protocol it should try to decode. So it's really important that these sync times doesn't interfere with other protocols which are out there. And for open protocol, those two sync times, they were decided in a meeting where all the different manufacturers of technology in this area today were present. Wemco was there as well, taking part in the discussion and choosing those intervals in order to make sure that it doesn't interfere. That's really important. Technically as well, the protocols are compatible with all current PPM receivers and tag equipment which is out there today. So if it's not applied to a certain kind of technology, that's just politics. And also for the length of each transmit. For the open protocol is quite short. It's really compact. So that doesn't make it any more vulnerable to collisions than any of the older protocols. Actually, some of the proprietary protocols which we use and other manufacturers use as well, they can be more prone to collisions because they're longer. So if you are in a dense setting where you have lots of transmits flying around in the water, if they are long, they are more prone to collide. So with open protocol, that's nice. It contains quite a lot of data and it's very secure. So last here I have two small sound clips, so you could try to hear the difference yourself. You can hear, if you're really closely listening, you can hear that the open protocol is a bit more, it's a bit faster, but it's a very little difference. And so it's not like a huge leap in technology here. It's just a small evolutionary step, and it's just an adaptation to make it to make something which is compatible with all the different manufacturers, and it is something we could use to cooperate and also compete and make more technology available to more people. That's the whole idea. So here I will play the two sound files for you. First, it's the I think it's in the OPI for ID43, and then there is an R64K code as the second sound clip there.
As we explore the benefits to open an interoperable system, it's helpful to look at two specific examples that actually parallel these kind of efforts. One is computer networking. 1969, the first connection of computers, of dissimilar computers, was over something called ARPANET, and was facilitated by the use of communications between different groups using something called RFCs, or request for comments, allowing for open communication between disparate institutions. This led to, in 1995, to the development of what's actually formally called the Internet, that defines a lot of the mechanisms for how computers and other kind of, not necessarily computers, of different devices, how they can be actually connected together. This in turn also developed into an evolution of physical means of connecting devices together, including the use of what's called the Ethernet, and also the use of Wi-Fi and other kind of connection mechanisms. And another example is looking at the USB port. Those of us that remember before 1992, connection of peripherals to PCs usually required a closet of connectors and cables, including PCI for high-speed communications, or DE9s for serial ports and others. But it was in 1992 that Intel actually defined a port called the USB port. And in 98, this port was actually adopted by both Microsoft and Apple for future products, and is now led to even some an evolution in higher performance and higher speed connections, such as USB 3 and USB-C. This kind of segues into what another part of this is, that what this fuels is innovation in technology, by allowing companies to focus on their strengths rather than constantly reinventing a new backbone. And it gives us such things as the jump drive, or the World Wide Web, and all the applications, including what allows us to actually be here together today. And of course, the innovation in pricing that allows this technology to be within reach of many different adopters.
Hi, I'm Stijn Bruneel, Doctor Assistant at the Research Group of Aquatic Ecology at Ghent University, and on behalf of ETN I will give you some information about the work we have been doing. To assess how the open protocol would work under different conditions, multiple field tests were conducted. More specifically, the aim of these tests was to assess the compatibility of the open protocol for ID and sensor tags of different manufacturers. Experiments were conducted in different countries: Belgium, Denmark, Portugal, and Spain, and in different habitats, including open sea, coastal waters, and rivers. Receiver and open protocol ID and sensor tags and encrypted tags of different manufacturers were placed at different distances to assess detection range. In these two pictures, you can see how the receivers of different manufacturers Thelma, Sonotronics, Lotek, and Innovatie are placed at the sea bottom near the sea power wind farm in the Belgian part of the North Sea. Besides moorings with receivers, also tags of different manufacturers Thelma, Sonotronics, Lotek, and Innovatie were positioned together. 4 moorings with receivers in blue and/or tags in white were placed at different distances to assess how the detection probability would change with distance. In this figure, results of the sea power wind farm in the Belgian part of the North Sea are depicted. You can see 12 different combinations of receiver and tag manufacturers. Detection probability is given in function of distance. The rows have receivers of the same manufacturer, while the columns have tags of the same manufacturer. The graphs in green depict combinations of which the tag and receiver are of the same manufacturer. Ideally, the detection range would not be determined by the manufacturer of the tags, and that is what we actually see here. The trends of the green graphs, so one manufacturer for tag and receiver in one row, are very similar to the non-green graphs, so tags and receivers of different manufacturers in that same specific row. This suggests that the open protocol works. However, we still need to analyze all the data sets of the other sites together and consider other aspects, such as false detections, double detections, etc., to have a full appreciation of what the open protocol has to offer, and what issues might still need to be resolved.
In conclusion, interoperable systems are the future. Opening the infrastructure networks of acoustic telemetry to all manufacturers will not only drive innovation, but will also boost availability of new solutions for future research. The open protocols have been validated and equipment is available. Thank you for joining us. You can find more information at the ETN tracking website with the URL listed below, or contact the ETN directly at the email below. Thank you.
And the first question is from Tadeusz. So Tadeusz, please, can you read out your question loud? And please unmute yourself. And I guess that your question is addressed to Stijn, right?
That's just technical question because I couldn't see the units on the graphs because they were too small. So nothing more.
Okay, so I guess that Stijn can answer this question.
Indeed, it was in meters.
Okay, thank you.
Okay.
Okay, Tadeusz?
What's the minimal size of transmitters? Because, you know, we are working on different animals and there are also freshwater biologists who are working with small fish or mussels or crayfish or something like that. then the minimal size of the transmitter is deciding about the technology applied.
I don't know, Erik or Marlin, if you want to address this, but I can start. So the transmitter size is a function of frequency. The two protocols discussed are currently being tested and operated at 69 kilohertz. So this is kind of your 6 mil kind of range, 6 millimeter diameter at the small side. We likely will progress to higher frequencies once there's take up of the initial 69 kilohertz. This was chosen as it's the most widely used frequency at the moment. But Erik, would you like to add anything, or Marlin?
I can just add that currently I think probably we got the smallest ones, and they're 6.3 millimeters in diameter. I don't think they will be very much smaller.
And lifetime of the smallest?
Please come again.
And lifetime of the smallest transmitter?
That depends on the how often they are transmitting, what they are measuring, and that kind of stuff. But
okay, but roughly.
If you do like a minute interval, you will get roughly like 3 months of lifetime.
Okay, thank you.
They can be longer as well, so you could add batteries. But that's I guess that's the current smallest ones.
Okay, thank you.
Right. Life tags generally are defined by three things. That there's the lifetime, the size, and the range. And typically you get to pick two, and physics picks the third. But I think right now we have about a 7 millimeter transmitter that's about in diameter and about 15 or 16 millimeters long. And likewise, you can extend the lifetime of these, like Erik was saying, to about 3 months with infrequent transmissions. But again, it's you have to look at those three factors about the lifetime size and what kind of range you're looking for. Those all they interact.
And as Dave said, with smaller tags, you need a higher frequency.
I have a question, if I may. So in terms of the open protocols, I was wondering if I were to have receivers that aren't operating on the open protocols and have tags that are, or vice versa, would I not detect anything, or would I detect some kind of noise that isn't interpretable in terms of like the raw data or the tag ID?
Yeah, so I'll let Erik and Marlin chime in if you like. The answer is it depends. So, for example, the Lotek receivers are for the open protocol are able to detect OPI, OPS, R64K, and also a legacy sensor protocol. But they also record all the raw pulses. So one can look at the raw data and it's available forever. So should you ever learn the specifics of another protocol that may or may not be encrypted or is proprietary to some other manufacturer, it would be essentially decipherable in post-processing. So the same would be true for OPI and OPS. Should a receiver that you happen to use actually record raw pulse data, but not have the ability to decipher OPI and OPS, you could in theory post-process it. But I'm not aware of receivers that do that at the moment outside of Lotek, Sonotronics. And Erik, you can speak to yours.
It's as you said, there isn't any problems with collisions. So because they use unique sync times, so having tags and receivers from different incompatible systems in the water at the same time shouldn't make any issues other than that you will add more sound in the water, more pings, if you have more tags. So if you have a setup with OPS or OPI tags from one of us manufacturers, and then you also have 69 kilohertz tags from another manufacturer, they will collide and use the same sound space, but they will not be detected on the different receivers.
Thank you.
Yeah, I don't think I have too much more to add, just that we, Sonotronics, as the, if you know ahead of time that you're interested in capturing that, the kind of the raw data information, will capture it, but in general, we don't. We just look for as Erik was talking about, these sync bytes, that identifies the tag of interest, and then we start making go through the process of decoding it. But if it doesn't meet that, when it isn't using one of those sync intervals, we just ignore it.
What about other manufacturers other than Lotek, Thelma, Sonotronics, and Wemco? So you mentioned StarOd. So StarOd is already open for OPIs and OPS?
I think I can answer to that. I don't think there are any from StarOd here today, or else they could answer themselves, but I'm not sure. Please chime in if you are here. But anyway, I was in contact with them just a couple of weeks ago, and then they said that they were working on making an acoustic tag out of their heart rate logger. So they are planning to produce a heart rate acoustic tag, and they're planning to do the first proper tests just after Christmas. That was the last update I got on that case. But they're proceeding, and they're doing good.
Yeah, and just to add to that answer, not with respect to StarOd, but just more broadly. So as stated in the presentation, the open protocols are essentially in the possession of the ETN, and they're managed by them. And so any manufacturer that is interested has the ability to engage with the ETN, sign the MOU, and then at which point they can begin essentially testing and determining whether or not they're going to develop equipment for the two protocols and any future protocols. And at the moment, I guess there's been essentially 6 companies that have been engaged in some capacity, and really 4 that have taken the step to develop and test equipment.
I have a question for Stigen. This was the first time I saw any of the data from the testing, so I just wonder when will it going to be published?
Yeah, well, that's a good question. Well, yeah, it's a new method, and so they're not only the technical issues that you have with new methods, but also like in data processing. So putting all this data together, making it nice into one nice data set that we can process took a little bit more time than we expected. But all these hurdles we are facing now, these are all also things that we can address later on. So it's not really time wasted, but it's difficult to say when we will have the results. And now we're actually making good progress. So we have this data sets, and now we can go further in other things and detection probability like this, false detections, double detections, etc. But specific dates, it's difficult to say.
Yeah, I understand. Sure, but it's cool to see that you're getting there. It's not easy to do that kind of tests. It's we've done it ourselves, so we know it's difficult. It's time consuming, definitely. But did you have time and opportunity to have the equipment out for longer time periods for testing, or is it more like shorter range test like setups where you have been gathering data for like half an hour or less?
So typical period was like 2 weeks. So, but we did different countries, different sites. So this was actually just the results of one location in one country, but we have different locations in different countries. And it was typically more than 1 week, typically 2 weeks of data that we collected. So it's actually quite a lot of data of a lot of different conditions. So,
cool. So you're actually looking at the data from all the different tests, not just from the Bliss test.
No, the idea is actually to indeed have all these different conditions and then to see how the open protocol works under all these different conditions.
Cool. Good work.
I have a quick question. I'm not sure who's the best place to answer it, but I guess at the start you mentioned that there was 1 million tag protocols within, and at the end, if theoretically, let's say we were very keen and used all of the tag protocols, would they be recycled at some point? I mean, is that the idea, or would the new mapping be developed or something? I'm not quite sure about that.
Yeah, so at the moment, there's an agreement with the ETN that they've assigned IDs from the two protocols to the manufacturers. So they say you get a block of IDs and you manage that ID space, meaning don't sell duplicate tags, and it essentially so confirm that with the group. Those tags do get registered, and the ETN will know who has them and whatnot. So should the system get mass adoption and become very much a functioning thing, is likely that the ETN will then adopt full ownership of ID management, where users would actually go and select, they would get IDs from the ETN. They then say potentially put out to tender, I'd like 25 tags of this size, this life, etc. Manufacturers would bid accordingly. And the manufacturer that was selected would then build for those IDs and those IDs specifically. If the IDs were used up, which would be in the OPI case, 1 million tags, they would absolutely get recycled.
And is there, just a little bit further, maybe it's my misunderstanding of it, is there a sort of a framework to protect the IDs as such? Or if someone else wanted to also use the same IDs, or is that just basically, on a sort of it's not really strictly within any legislation, but it's just a pact that is sort of made. Is that the idea?
Yeah, I would say it's an agreement or pact between the manufacturers and the ETN in this case, that there's language in there that restricts certain things. But it's a fair question, really. There's nothing stopping, someone from polluting the waterways with noise. And when I say someone, I don't necessarily mean a manufacturer of equipment, but, someone who's just a terrorist in a way.
Cool.
Yeah.
To be fair, I mean, it's an interesting analog to look at the internet in particular, and the use of what the physical addresses for such things called MAC addresses that are managed by an international organization. But there's actually it's just good behavior that dictates that people don't go ahead and use things that don't belong to them, and it's worked out pretty well. I think generally people seem to recognize that good behavior is much better than the alternative.
I would also add that in the telemetry world, in the animal research world,
it seems that we lost Marlin. Probably his connection has.
Sorry, Donna, go ahead. I could hear Marlin too.
Yeah, I could hear Marlin fine. I was just pointing out that in the animal tracking world, I'm not sure if everybody's familiar with the Argos satellite system that manages the tag IDs associated with all satellite transmitters that are used on animals for tracking purposes. The model is very similar here in that the ETN would essentially house and allocate the IDs. Thereby, you do have some measure, certainly have a good measure of control in terms of reducing the duplicate. So the only alternative would be, as Dave mentioned, that if someone maliciously decided to duplicate IDs to create some havoc. But Argos has been in operation for many, many years, and to my knowledge, that hasn't happened.
Yeah, just adding to that, the protocols itself, they are not open, as in openly available to everyone. It's you have to sign the memorandum of understanding, and then you get access to the details which is needed to produce the intervals and a meaningful code. So it's not out there for everyone to just implement. You have to first sign with the ETN, and then you get access to the details, and then you can start producing.
Yeah, we hopefully, hopefully we actually do get to a place where the sort of activities we're talking about become illegal and punishable by law, because that means there would be mass adoption essentially, and they would be much further advanced for scientific purposes, which is what we see in like the cell phone networks, for example. It's relatively straightforward to create a device that would jam cell phones within an area. But if one did that and was caught, which it is somewhat, it's not impossible to catch someone doing that. Obviously, they would be reprimanded and, seek legal action in whatever jurisdiction they're in. Well, Marie, if there's no further questions.
Yeah, I just wanted to ask the audience whether we have another question or comment, and it doesn't seem so. So I thank you everyone for joining us today, and we are really sorry for the inconvenience due to some minor loss of connectivity or something like this. So in case you want to review the presentation, it will be available on ETN YouTube channel. Okay, so stay tuned for telemetry, and we will meet you again the next week, because the next week we will have two webinars, one on study design, which will be presented by OTN guy Joe Pratt and Jan Johnson from Macquarie University. And also there will be a webinar on data analysis run by Bliss and Inbo guys. It will be on the R package, how to analyze your telemetry data. So in case you want to join these two webinars, be sure that you will find a reminder of this webinar the next week in your mailbox. Okay, everyone, do you want to say something?
Thank you.
Nice, thanks. We thank you for your patience and questions. Yeah, and also we are very grateful for Donna, Dave, Tanya, Stijn, Marlin, and Erik for the presentation. They are preparing the presentation for us in past weeks very carefully. Yeah, thank you very much.